Welcome back. Today we're going to talk about complex zeros. We've already gone through the process of trying to find the real zeros using the graphs, using factorizations, using synthetic division. And so today we're going to talk about complex zeros and what that means for us in terms of the functions that we have. Let's start with the Fundamental Theorem of Algebra. The Fundamental Theorem of Algebra says that a polynomial of degree n, for example, x to the fifth, okay, has n complex zeros. And the thing about this is, when they're complex, they could be real or non-real. Okay, so we could have, x equals 2, we could have x equals minus 3i, something like that. The other trick to this is that some could be repeated. Okay, so your multiplicity could be 2, and those would still count towards your zero count. The linear factorization theorem, so we're going to talk about a couple of theorems. So that tells us, hey, when I've got a polynomial of degree 4, it's got 4 zeros, real, non-real, multiplicities, those sorts of things. So, you can already start to see, like, if I'm going to write this out as factors, I need to have the same number as the degree. Linear factorization theorem says this: a polynomial of degree n, talking about that same one, has n linear factors. Looks like this. F of x is equal to a times x minus some number, we'll call it z1, times x minus some other number, z2. And we would continue to have linear factors all the way until we got to x minus z sub n. It would have n linear factors. Okay, and so this is a linear factor. Okay, so it'd be like x minus 3. Obviously, if you graphed x minus 3 by itself, that would be a line. So that's a linear factor. My a here is my lead coefficient. Two important things to know about these two theorems, okay? Number one, these are existence theorems. They're existence theorems. It says n complex zeros exist. N linear factors exist. Doesn't tell you how to find them. That's the first point. The second point is this can help you make sure you have them all. So if you know you're supposed to have 5 zeros, 5 linear factors, and you only have 4, you need to keep looking, or you've missed something. So that can help you check it once you get to these problems where we're asking you to find all of the zeros. All right, let's do a couple of problems to review this concept of linear factors and also complex zeros. Write the polynomial in standard form. So that would be, for example, something like this. Now, obviously, when we get to example B, we're going to have a cubic. So standard form is going to tell us, we've got to have our powers in decreasing order. And so as I look at this, these are those linear factors I was talking about up here. And so I know this is going to be an x squared function because I have 2 x's. And so I'm going to go ahead and multiply out. So I've got x squared plus 2ix minus 2ix minus 4I squared. If you think back to what we've talked about before in terms of complex numbers and our i's, we know that these two cancel out, and if I've got minus 4I squared, that would be minus 4 times minus 1, so it would be plus 4. And so x squared plus 4 is my polynomial in standard form. A couple of notes about this. One, this function has two zeros. They are 2i and negative 2i, x minus k, so those would be my two zeros. Which also means that, if those are imaginary, this one wouldn't touch our x-axis. So we can glean some information from these things. Okay, so I want you to go ahead and try B on your own. Pause the video here, and when you come back and start it up, I'll be working on this problem with you, and you can see if you got it right. Okay, so pause it here and try that one. All right, we're back. I am going to do this part first because I want to get those i's out of the way so I don't have to deal with them twice. And so if I start working here, I've got x squared. I've got plus root 2ix minus root 2ix minus root 2i root 2i. So if I simplify this, I've got x squared, these go away, and then I've got minus root 2 times root 2 times I squared, x squared minus 2i squared, which gives me x squared plus 2. Okay. So I just reordered these to put my square root of 2's together because I know square root of 2 times square root of 2 is equal to 2. So if I bring down my other linear factor, I've got x minus 5. And so now I've got x minus 5 times x squared plus 2. X cubed plus 2x minus 5x squared minus 10. Well, if I'm trying to put this in standard form, I've got to do a little bit of reordering here. And I'll just have my x cubed minus 5x squared plus 2x minus 10. Okay, that's all you would need to do. Just of note, I've got three zeros. Okay, my three zeros are 5 and minus root 2i and root 2i. Because any of these factors of this polynomial could be set equal to 0. So all of these things are related. Linear factors, zeros, those sorts of things. Okay, what you've noticed in the last two, maybe you've noticed, maybe you haven't, is I had 2i, I had negative 2i. I had negative root 2i, I had root 2i. It's not a coincidence that these complex zeros come in pairs like that. And the complex conjugate zeros, if we have, excuse me, if a polynomial has real coefficients, okay, so it's got real coefficients. So these two end up with real coefficients. X squared plus 4, x cubed minus 5x squared plus 2x minus 10. So those are real coefficients. And a plus bi is a 0. Then a minus bi is also a 0. Okay, and the reason why that works is because if a plus bi, excuse me, a plus bi is given as a 0, in order to kind of counteract that or for them to cancel out, to give us only real coefficients, they both have to be. So a plus bi and a minus bi. Let's do an example. It says, write a polynomial function of minimum degree in standard form with real coefficients whose zeros include 3, 4, and 2 minus I. So what I'm going to do first is I'm just going to write out my zeros. So my zeros are -3, 4, and 2 minus I. Real coefficients means that I don't have any imaginary coefficients, which means that if I have 2 minus I, I'm also going to have 2 plus I as one of my zeros, okay? And so real coefficients dictates that, complex conjugate, it's going to have to be there. All right. So this means I have 4 linear factors. Okay? And they're going to be this. All of my x minus k's. So f of x is going to be equal to x minus a minus 3, so x plus 3, x minus 4, x minus 2 minus I, and x minus 2 plus I. Okay, so already you can kind of see and fast forward to the end. You can kind of see and fast forward to the end. You can see this is going to be a polynomial with a fourth, okay, to the fourth power, fourth degree polynomial, because I've got an x, an x, an x, and an x. So now I've got to do a little bit of grunt work to do my multiplications here. So let's go to work. I've got x squared minus 4x plus 3x minus 12. So this gives me x squared minus x minus 12. That's that part. Okay, let's work on this business here. If I simplify, x minus 2, so I distribute this negative into here to make it a little bit easier. So I've got a minus 2 and then plus I, and then this one's going to be x minus 2 minus I. And I start to do some multiplication here. Here we go, x squared minus 2x minus ix minus 2x plus 4 plus 2I. Got to keep going. Pick a different color. Plus ix minus 2I minus I squared. Okay, so a couple things are going to combine and or cancel out. Let me grab a different little color here. I've got x squared, so I'll use that one. I've got minus 2x minus 2x, so that would be minus 4x. I've got minus ix plus ix, so those cancel out. I've got plus 2I minus 2I, so those cancel out. And I've got a plus 4 and then minus I squared. Well, minus I squared is going to be minus a negative 1, and so that's going to be a plus 1, x squared minus 4x plus 5. And I've still got my x squared here, minus x minus 12. So here we go, back to multiplying. So I'm going to have x to the fourth minus 4x cubed plus 5x squared minus x cubed plus 4x squared plus negative 5x. Going to keep going. By the time I get to that third one, I want a different color. So I've got minus 12x squared plus 48x minus 60. All right, let's combine like terms here. I've got an x to the fourth, and that makes sense because at the beginning I said I've got 4 linear factors, 4 zeros, so that's going to give me my my highest degree term. I use that one. X cubed and x cubed, so minus 5x cubed. 5x squared and 4x squared and minus 12x squared would be minus 3x squared. Got a minus 5x and a 48x plus 43x minus 60. That's my f of x. So not anything we don't know how to do, just a lot of work on the front end to get that all figured out. Okay? So for this next one, I want you to try it. So go in, pause this video, try it, and when we come back, I'm going to show you exactly how it's done. All right, we're back. Okay, so if we do this one, let's check out our zeros. Our zeros are 2, 3, and I. But because it has real coefficients, important to remember, if I've got an I as a 0, I also have minus I as a 0. And so I've got 4 zeros, so I know I'm going to have a 4th degree polynomial. Let's write out our linear factors. Linear factors. For our linear factors, we're going to have x minus 2, x minus 3, x minus I, and x plus I. Okay, so those are going to be our 4 linear factors, and we're going to do some multiplication, some distributive property. Let's work on these first. X squared plus ix minus ix minus I squared. So that's going to give me x squared plus 1 for that part. My next part, x squared minus 3x minus 2x plus 6. Simplify. X squared minus 5x plus 6. So I've got my 2 polynomials, and all I need to do is go ahead and multiply them together. X squared times x squared, so that gives me x to the 4th. I've got x squared times 1, which gives me x squared. I've got minus 5x times x squared, which would be minus 5x cubed, minus 5x times 1, which would be minus 5x. 6 times x squared would be plus 6x squared, and 6 times 1 would be 6. Okay, so now we've got all our pieces in place. Let's do a little bit of rearranging. So my f of x is equal to x to the 4th minus 5x cubed plus 7x squared minus 5x plus 6. And so that's my linear factors. So I took my zeros, made sure I had them all, made them into linear factors, did my distributive property to write a function of minimum degree with real coefficients that include those zeros. Okay? That's how we do it, guys. Thanks for watching, and we'll see you next time.